In this video, we're going to learn about using supplementary angles to prove congruent triangles. So when you first look at this example here, we have, let's go ahead and just kind of mark up our picture. We have AP is congruent to CP, so these two segments are congruent. Angle X and angle Y are congruent. And basically, this is just telling us we have a straight line BPD. You don't really need to worry about this given. So that's not really telling us anything other than that we have a straight line right there. So we can already assume that. And what our goal is to prove triangle ABP. So this triangle is congruent to triangle CBP. And what I notice is, one, I see the reflexive property. I see where those highlighters change color, so I see that. And I also have these other sides, and then I have two angles that are not included in the two triangles. So that's kind of like a red flag here. The fact that we know angle X and Y are congruent, but they're not in the triangles we're trying to prove, that tells me I'm going to need to do something further with those angles. So what I'm going to do is I'm going to put angle 1 here in angle 2. And now what I notice is angle X and angle 1 are supplementary, as well as angle Y and angle 2 are supplementary. So if you think about it, these two angles add to 180, and these two angles add to 180. And if X and Y are the same, let's just pretend for a second that they're both 80 degrees, well then that would mean that angles 1 and 2 both have to be 100 degrees and therefore are equal. So this is called the congruent supplements theorem. And that's going to be whenever you have supplements of congruent angles, they have to be congruent to each other. So that's going to allow me to then get angle 1 and 2 congruent, and then I can use side, angle, side with the angles inside of the triangle in between the two congruent sides. So let me kind of write down what I just said. So we have AP is congruent to CP. That was a given. And then I had angle X and angle Y congruent. That was a given. Notice that these are lowercase letters too because we're talking about the space. It's not a point. That's why it's not a capital letter. And then I made a couple conclusions. I said that angle 1 is supplementary to angle X, and angle 2 is supplementary to angle Y. And this is because two angles that form a line are supplementary. Or I could say a linear pair implies supplementary angles, something along those lines. Something about the two angles that are forming this line making the angle supplementary. And then the other thing I concluded from the picture was the reflexive property. So again, that's just kind of floating as well, a floating statement, because I was able to conclude that from the diagram. So this is reflexive. So basically, I have all of these statements that I have written down. These are all things that I either concluded from the diagram, so the supplementary reflexive, or they were given to me. So there's nothing that they're connecting to. And now when I piece some of these together, I can piece these two together because since angle 1 and angle 2 are supplementary to congruent angles, angle X and angle Y. So again, like we said, if angle X and Y were both 80, well then 1 and 2 have to be congruent. They would have to be 100 if that was a specific number we were talking about. So if I pair these two together, knowing that X and Y are congruent and knowing that 1 is supplementary to X and 2 is supplementary to Y, I know that angle 1 must be equal to angle 2, no matter what the angle measures are of X and Y. Since X and Y are equal and they're supplementary to 1 and 2, 1 and 2 have to be congruent by the congruent supplements theorem. So that's what this is called, congruent supplements theorem. You could also say supplements of congruent angles are congruent. 1 and 2 are supplements of congruent angles, X and Y, so therefore they're congruent. You could write it out. And then what I said was, so now I can mark this in my picture. So this is side angle side, the angle in between the two sides. Notice again that the angles have to be in the triangle. So then when I look at my proof here, I have one side right here. My angles are the 1 and 2, and then the reflexive property counts as my other S for my SAS. So then if I pair these all together, this allows me to say that the triangles are congruent. So triangle AP or ABP is congruent to triangle CBP by side angle side. And I have everything, I've checked it all off. I highlighted it as I checked it, so we're all good. So remember, the congruence theorems, you should always have 3 things coming to why the triangles are congruent, because there's always 3 things that are required. So let's look at one more example here. So I have in this picture CDE, so CDE is congruent to angle CED. I have AD is congruent to BE, and CD is congruent to CE. And I'm trying to prove that ACD, I'm trying to prove this triangle is congruent to BCE. So again, I look at my picture and I see that I have 2 sets of congruent sides in these yellow triangles, but notice that my angles are outside of the congruent triangles. And those angles happen to form a straight line with the angles in the inside of the triangles. So angles 1 and 2 are the angles that I really need, and I can get those because I know that angle 1 is supplementary to CDE, angle 2 is supplementary to CED, and since these 2 angles in this other triangle are congruent to each other, therefore 1 and 2 have to be congruent. So we can go ahead and write this up. So I can say CDE is congruent to CED. So that was given. I also am going to go ahead and say that we have these supplementary angles here because the angles form a straight line. That's a conclusion I can make from the diagram. So I'm going to go ahead and say CDE is supplementary. So CDE is supplementary to angle 1. CED, so this angle over here, is supplementary to angle 2. And that is something I can conclude from the diagram. So 2 angles that form a line are supplementary. And then I have these other givens. So AD is congruent to BE. That was given to me as a set of sides. And I was also given CD is congruent to CE. And using this new idea, the supplements of congruent angles are congruent. Since I know that these angles right here are congruent, that's going to force angles 1 and 2 to also be congruent. They have to be the same measure if they add up to 180 degrees with congruent angles. So angle 1 is congruent to angle 2 by the congruent supplements theorem. And in order to use this congruent supplements theorem, you always have to have these 2 steps. You have to know a pair of congruent angles, and they have to be supplementary to the pair of angles that you're trying to prove congruent. And then from here, I can mark my picture with those, and I can now see in the yellow triangles that I have side angle side. So when I go to piece these together, here's my angles, here's a pair of sides, here's the other pair of sides. So I can say triangle ACD is congruent to triangle BCE by side angle side. And again, just to verify that, we have the angles, the included angles, we have the included sides, or the sides that make up the included angle right there. So there's my 3 things to be able to say side angle side. So there we have it, another theorem, but still in the end, we're always trying to get down to one of our 5 methods to be able to prove these triangles congruent. So we are just going to look for anytime there's angles outside of the triangles that you're trying to prove, look to see if those angles happen to be supplementary to angles inside of the triangle, because that usually indicates you're going to use the congruent supplements theorem. So go ahead and write down some key ideas and try the check your understanding problem.